Credit card fraud detection using classification, unsupervised, neural networks models. Abstract, nowadays online transactions have grown in large quantities. Among them, online credit card transactions hold a huge share. Therefore, there is much need for credit card fraud detection applications in banks and financial business. Credit card fraud purposes may be to obtain goods without paying or to obtain unauthorized funds from an account. With the demand for money, credit card fraud events became common. This results in a huge loss in finances to the cardholder. Confusion_matrix equals confusion matrix, y_right, y_predicted. Print, confusion matrix \n%s% confusion_matrix. Confusion_matrix dot plot, normalized equals true. plt.show. Confusion_matrix dot print_stats. Previously they used the most common methods like rule induction techniques, fuzzy system, decision trees, support vector machines, SVM, k-nearest neighbor algorithms to detect the fraud transaction using a credit card. From our perspective, neural networks will generate more accurate results. To increase the accuracy and precision, we use the algorithms logistic regression, k-means, convolution neural networks. Logistic regression is a statistical model that tries to minimize the cost of how wrong a prediction is. CNN algorithm is used to capture the intrinsic patterns of fraud behaviors learned from labeled data. So we'll make use of accuracy and precision to evaluate the performance of the proposed system. Keywords: CNN, credit card, fraud detection, logistic regression, k-means. Introduction. The rising of e-commerce business has resulted in a gentle growth within the usage of credit cards for online transactions and purchases. With the rise in the usage of credit cards, the number of fraud cases has also been doubled. Credit card frauds are those which are done with an intention to gain money in a deceptive manner without the knowledge of the cardholder. A credit card fraud can be done in the subsequent ways. 1. Fake IDs. This type of fraud is done by using the personal information of other persons without any authorization. 2. Skimming method. This type of fraud is done by installing a device called skimmer at ATM machines. The data present on the magnetic stripe of the card is collected when the card is swiped. 3. Card not present. When the fraudster steals the data like the expiry date and account number of the card, they can use the card without being possessed physically. 4. False business person sites. This type of fraud is done by the method phishing, where they create a website/web page which looks similar to that of the original site. Detecting fraud is extremely difficult. A large variety of parameters are used to choose and classify. Transactions cannot be classified into fraud/genuine strictly. However, can be found by the intensive study of the defraudment habits, customers' behavior, and by analyzing pre-fraud patterns. Several challenges are faced by fraud detection techniques as they need to detect the fraud in a very short time and large parameters ought to be processed while training. In our paper, we compared the techniques to evaluate, which gives the most effective performance underneath what conditions. Logistic regression, k-means, and convolution neural networks algorithms are used to achieve high accuracy rates and to increase the detection process. Convolution neural networks are used to identify the underlying patterns that are followed in the previous cases and thereby increasing efficiency. 2. Literature survey. In 2019, Yashvin Jain, Namrata Tiwari proposed the comparative study of all the existing systems, i.e. support vector machines, Bayesian network, artificial neural networks, present to detect the credit card frauds. In 2, they discussed the performance of logistic regression, decision tree, and random forest to detect the fraud. In 3, this paper discusses the probability of fraudulent transactions in prevalence and context of credit card usage. 3. Methodology. 3.1 Architecture. C:\users\hp user \documents\4year project \capture archi, 2.png. In the very step, We downloaded the dataset from the website Kaggle and the link is www.kaggle.com web link. Initially, the dataset is read carefully and understood. Next, the dataset is sampled, i.e. a part of the dataset is taken for observation and pre-processing is done. Here, the unwanted data is removed if necessary. After data pre-processing, the dataset is divided for training and testing. We divided 75% of the dataset for training and the remaining 25% of the dataset for testing. The next step is to create the models for the dataset. The architecture contains 3 types of models. Each model falls under a different category. The models are logistic regression, which comes under classification, k-means, which comes under clustering, and convolutional neural networks, which comes under neural networks. Next, the testing data is taken and predicted with the help of trained data. Finally, the results are noted. Performance and the accuracy for each model are observed and the best model is to be found. 3.2 Models for detecting credit card fraud. Logistic equals linear underscore model dot logistic regression, C equals 1E5. Logistic dot fit, X underscore train, Y underscore train. Print, score, logistic dot score, X underscore test, Y underscore test, P. The models that we have used for detecting the credit card fraud are 1. Logistic regression, 2. K-means, 3. Convolutional neural networks. 3.2.1 Logistic regression. The logistic regression is a classification model used mainly for the binary classification datasets. Since our dataset is a classification dataset, we use this logistic regression. It mainly classifies the dataset into 2 binary values finally, which are zeros and ones, to detect the fraud in the credit card transaction. Initially, the dataset is loaded with the help of the pandas library. In the next step, the dataset is split into X and Y values and sizes are printed. For training and testing, we will use the train underscore test underscore split method, and the test underscore size is given as 25% as shown below. X equals df dot eloc colon comma colon dash 1. Y equals df class. Print, X and Y sizes, respectively, len, X, len, Y. X underscore train, X underscore test, Y underscore train, Y underscore test equals train underscore test underscore split, X, Y, test underscore size equals 0.25. After the division of the dataset into training and testing size, logistic regression model is implemented on divided dataset. In this model, first we should train the dataset and next testing is done for the remaining data with the help of prediction method. The logistic score that we got here is 99.88%. Finally, the binary confusion matrix is noted for this logistic regression with the usage of method confusion matrix, method. The status of the confusion matrix are 3.2.2 K-means. K-means clustering algorithm is one of the unsupervised machine learning algorithms. This K-means algorithm groups similar data points together and finds the underlying patterns. To obtain these clusters should be formed. Here the clusters are nothing but centroids. Here in this K-means model, we used PCA to reduce the dataset attributes into 2 components, and scaling is also done for them. Then we used the train underscore test underscore split method for training and testing. X equals df dot eloc colon comma colon dash 1. Y equals df class. X underscore scaled equals scale, X. PCA equals PCA, N underscore components equals 2. X underscore reduced equals PCA dot fit underscore transform, X underscore scaled. X underscore train, X underscore test, Y underscore train, Y underscore test equals train underscore test underscore split, X underscore reduced, Y, test underscore size equals 0.33, random underscore state equals 500. From here the implementation of the K-means algorithm starts. To create a K-means model we use K-means method as shown below with 2 clusters. K-means equals K-means, init equals k-means plus plus, n underscore clusters equals 2, n underscore init equals 10. K-means dot fit, x underscore train. After fitting the model, the output looks like output. With this, the k-means model is created, and next, we should form clusters by creating centroids in the model and grouping the nearest data points to the nearest cluster. Since this algorithm works well on an unsupervised dataset, this algorithm can't give good results for our dataset. After forming centroids for clusters, if we plot the graph for k-means, it looks like as shown below. K-means, algorithm equals auto, copy underscore x equals true, init equals k-means plus plus, max underscore it here equals 300. N underscore clusters equals 2, n underscore init equals 10, n underscore jobs equals 1, precompute underscore distances equals auto. Random underscore state equals none, toll equals 0.0001, verbose equals 0. Model.fit, x underscore train dot as underscore matrix, y underscore train, epochs equals 1. Figure, k-means clustering on the credit card fraud dataset. In the above figure, the centroids are marked with white cross. Here we have 2 white crosses. So, we have 2 centroids for our dataset. This model gives a test accuracy of 54.27%. This is because this algorithm works only on an unsupervised dataset. Model 2 equals sequential. Model 2.add, dense, 10, input underscore dim equals 10, activation equals relu. Model 2.add, dense, 27, activation equals relu. Model 2.add, dense, 20, activation equals relu. Model 2.add, dense, 15, activation equals relu. Model 2.add, dense, 1, activation equals sigmoid. Model 2.compile, loss equals binary underscore cross entropy, optimizer equals atom, metrics equals accuracy. Model 2.summary. 3.2.3 Convolutional neural networks. The convolutional neural networks is a neural network algorithm mainly used for classifying and detecting the image. But we can also use this in credit card fraud detection. Initially, the dataset is loaded and split for training and testing purposes with the ratio 75:25 as shown below. X underscore train, X underscore test, Y underscore train, Y underscore test equals train underscore test underscore split, X, Y, test underscore size equals 0.25. A. Simple neural networks. To create a neural network, we sequential method. Initially, we created only 2 hidden layers in this model. Even though the accuracy is good but the loss value is high. The summary of the model that created is: model equals sequential. Model.add, dense, 30, input underscore dim equals 30, activation equals relu. Model.add, dense, 1, activation equals sigmoid. Model.compile, loss equals binary underscore cross entropy, optimizer equals atom, metrics equals accuracy. Model.summary. Fig.5. Neural networks with PCA, 10 components. After fitting this model, we got a 99.67% accuracy rate but with a high loss value rate, which is 99.785%. It has used only one epoch for iteration. Output: epoch 1/1. B. Neural networks with PCA, 10 components. In the simple neural network, it got high loss value. To decrease this loss value, we create more hidden layers. We have created 5 hidden layers in this model. To create a neural network, we use sequential method as shown. The summary for this 5 hidden layer model is: confusion underscore matrix 2 equals confusion matrix, y2 underscore correct, y2 underscore predicted. Print, confusion matrix backslash n%s% confusion underscore matrix 2. Confusion underscore matrix 2 dot plot, normalized equals true. plt.show. Confusion_matrix2.print_stats. Fig.5 Neural networks with PCA, 10 components. After the creation of the model, the PCA reduced components are used for testing using 5 epochs. By using 5 epochs we will get finally an accuracy rate of 99.99% with less loss value 0.038%. x2_test equals pca.fit_transform, x_test. h equals model2.fit, x2, y2, epochs equals 5, validation_data equals x2_test, y_test. Output. Train on 380,962 samples, validate on 93,987 samples. Finally, the performance of this model is evaluated by using the binary confusion matrix. The confusion matrix is created with usage of confusion matrix method and also plotted with matplot library. 4. Model comparison. Among the 3 models, logistic regression outperformed well. This is due to the changing of decision boundary with the class weights features. After logistic regression, the better one is the convolutional neural networks and the k-means has the poorest performance. K-means has the poorest performance because it works with the clustering process and this clustering entirely depends on finding similarities and differences in the features from the dataset and grouping them into clusters. Here for this dataset grouping is a difficult task because fraud and genuine transactions look very similar. So, it is very difficult to put the fraud and genuine transactions into separate groups. The logistic regression gave us the best result among the 3 models. The accuracy rate for the logistic regression model is 99.88% with 0.079% of the validation set being false. Finally, there were the best results for logistic regression with balanced weights. The accuracy rate is 97.5% for logistic regression with balanced weights. The convolutional neural network model stands next to logistic regression in showing better results. For the simple neural network, we got an accuracy rate of 99.61% and the loss rate is 99.87%. So, to decrease the loss we have used multiple inner layers. Here, we have also used principal component analysis, PCA. For these multiple inner layers the accuracy rate is 99.9% and the loss is reduced to 0.037%. Along with this, the validation accuracy is 47.05%. The k-means clustering model has the poorest performance on the dataset. Because the dataset we have taken is a classification dataset. We should classify the dataset into zeros and ones in the dependent attribute named class. K-means has a low accuracy rate of 54.27%. Of the wrongly predicted transactions, 99.75% were false positives, giving only 0.24% false negatives with 0.11% of the validation set. Accuracy table. V. Conclusion. It was clear from the model results that the logistic regression model performed well on our dataset. After the logistic regression model, the next better model is the neural networks model because of more hidden layers. K-means model has poor performance on our dataset. This K-means model works efficiently on an unsupervised dataset. In addition to our model, there are many other submissions on our project with the random forest model is the most common which also works very efficiently. So, the logistic regression model works effectively on the credit card fraud dataset with the binary classification process.